In the 10 MCQ, we're looking at a reaction that could be taking place in a catalytic converter. Now, I will regard this as a rather important green question, very environmentally relatable question under the chapter of air and atmosphere. So let's first start out by drawing the catalytic converter. You're going to see a honeycomb structure here. And this honeycomb structure actually comes on with the intention of increasing the exposed surface area whereby the reactants will be coming into contact with the catalyst. Now, catalysts themselves, they provide an alternate pathway. This alternate pathway serves to reduce the activation energy. And with a decrease in activation energy, this actually increases the proportion of reactants with energy that is more than or equals to activation energy, ultimately increasing the frequency of effective collision, resulting in a much faster speed of reaction. And oftentimes, catalysts are considered to be transition metals. So it's imperative that you remember the choice of transition metal for your catalytic converter, and that includes platinum, palladium, as well as rhodium. Now, next important is the pollutants that are entering the catalytic converter. First up, we have carbon monoxide. Now, carbon monoxide is considered to be a rather harmful gas because if you are a biology student, you know that it decreases the oxygen carrying capacity of your blood by binding to hemoglobin at a much higher affinity than oxygen, forming carboxyhemoglobin instead of oxyhemoglobin. So upon entering the catalytic converter, what comes out from there is the formation of carbon dioxide. Now you can see that carbon monoxide has actually gained a single oxygen, and this can be deemed as an act of oxidation. However, if you're going with the oxidation state, carbon monoxide, carbon has an oxidation state of +2, but by the time it becomes carbon dioxide, it became +4. And the increase of oxidation state is aligned to an oxidation event happening. The next pollutant that we're seeing coming in, they are considered to be the oxides of nitrogen. Now, oxides of nitrogen, we have a few examples. The neutral one, which is nitrogen monoxide, or you have your nitrogen dioxide. Now, this item itself, particularly your NO2, when it actually enters the atmosphere, it can combine with water to give rise to acid rain. And after going through the catalytic converter, nitrogen gas is actually exiting from there. And doing a comparison here, you can see that N2 has actually been the result of NO or NO2 losing oxygen, otherwise going through the process of reduction. But again, if we're going with oxidation state, the nitrogen in nitrogen monoxide is holding that of a +2, for the nitrogen in NO2 is holding an oxidation state of +4. But by the time it hits into elemental nitrogen, it has an oxidation state of only 0, both showing a decrease in oxidation state aligned with reduction. Now, the other common reaction that can happen is with regards to the unburned hydrocarbons. Hydrocarbons are a compound that only contains carbon and hydrogen. And the end result is actually the production of CO2 as well as H2O, which you can see that in both cases, the elements that's found in your unburned hydrocarbon, C and H, have actually gained oxygen, meaning the unburned hydrocarbon has undergone the process of oxidation as well. So going back and checking on the equations that has taken place, we will not be expecting A itself. We do not want CO to be produced. For B, this is the correct answer. Monoxide oxidized to CO2, whereas nitrogen monoxide reduces to N2. For the case of C, NO2, there should be an entrance into the catalytic converter, but the end product shouldn't have been nitrogen monoxide, but nitrogen gas. And for D, CO2 should not have been converted to CO, it should have been the other way around. Same thing, NO should not have been converted to NO2, both should have actually been converted to N2. Again, the correct answer for this question is B.